Good afternoon. My name is Diana Waring. I'm the director of the Department of the Interior Museum, and it's my pleasure to welcome you here this afternoon for the latest installment of our monthly lecture series. As many of you know, these lectures encompass a wide range of topics, historical, environmental, scientific, to reflect the diverse workings of our bureaus here at the Department of the Interior and the Interior as a whole, both past and present. A quick bit of housekeeping before we get started is that on your seats you all have a feedback form. We encourage you to fill these out and deposit them in the tray outside at the conclusion of the lecture. Your input really does help us make this series the best that it can be. And in terms of lectures coming up, in January, Doug Piatowski from U.S. Geological Survey and Kristen Hart from the Bureau of Ocean Energy and Management will be talking about their collaborative projects, learning about sea turtle behavior and the impact dredging has on them. In February, Peter McGowan from the U.S. Fish and Wildlife Service will be talking about ecosystem restoration at Poplar Island, which is near Baltimore, Maryland. But turning to today's presentation and today's presenter, Levi Brekke has worked with the Bureau of Reclamation for over 15 years as the chief of the Research and Development Office. Levi oversees two programs, Science and Technology and Desalination and Water Purification Research. Levi provides strategic direction and facilitates collaborations between Reclamation's research personnel, resource managers, stakeholders, and the water management community at large. Levi's background includes water resources planning, water and wastewater treatment engineering, and climate adaptation research. Levi's education includes a BSc degree in civil engineering from the University of Iowa, MS degree in environmental science and engineering from Stanford University, and a Ph.D. in water resources engineering from the University of California, Berkeley. Please join me in welcoming Levi Brekke.
All right. Well, thank you very much. I appreciate the opportunity to be here and share about water and power research and development at the Bureau of Reclamation. For folks who are unfamiliar with Reclamation, we are a Western U.S. water management agency. You can think of us as the largest wholesaler of water in the country. We're very much on supply side management. We're the second largest generator of hydropower as well. Our footprint is the western 17 contiguous states. On this map you see where we have facilities. So there's the yellow dots are where there are dams and reservoirs that we manage, and the red circles are where we have hydropower generation facilities. To understand Reclamation's mission, you would do well to start thinking about the mountain watersheds in the west. We collect a lot of surface water resources from these basins, and we collect them in reservoirs behind dams that have been constructed many years ago, 50 to 100 years ago. A lot of these dams were developed. Today, we've evolved into a contemporary water management agency where we aim to manage the water resource in these reservoirs to equitably serve downstream beneficial uses. So one example type of use that we serve, a key type of use, is irrigated agriculture in the West. The Western climate is, in terms of rain-fed agriculture, it's not very favorable for agriculture, but the lands are very fertile in valleys and lowlands, and irrigation has been a way of ag for well over a century, and our systems serve 1 out of 5 Western farmers. In addition to irrigated agriculture, we also deliver water to urban areas, major metropolitan areas in the West. In the course of delivering water, we release water through those dams, like you saw, and we are generating hydroelectricity, which adds to our nation's energy supply and portfolio. These photos are from the Grand Coulee power plant and show various generators and one hydro machine that's on an planned outage, so it can be retrofitted. In addition to delivering water, generating hydropower, we're also releasing water from these reservoirs to meet various downstream environmental purposes. That may be delivering water for riparian habitat, wetlands, there may be lake level management behind the dam, and also releasing water on schedule to benefit downstream fisheries. So Reclamation's mission is pretty diverse. So the R&D office in Reclamation, it exists to help address various technical challenges that affect how we do our mission. And these challenges occur in a wide space of problems. So there are challenges with managing an aging fleet of water infrastructure, challenges with generating power and energy, environmental issues in water management, there's challenges in water operations and planning, better decision support tools, and also just expanding our water supply. So in the West, there's always this tension of supply versus demand. Generally, supply is a scarce resource. And so we're looking for technologies that will help us expand supplies and close that gap. Our primary customers in Reclamation are our own facility and resource managers, our customers and stakeholders, but we also see that being federally funded R&D programs, the general American public and the private sector are also key stakeholders in what we do. And as you heard in the introduction, we administer 2 programs in the R&D office. One is the Desalination and Water Purification Research Program. It really focuses on that developing water supplies area, and specifically through the application of water treatment technologies, so we can convert non-traditional water sources into usable water supplies. The Science and Technology Program, it covers the full spectrum of challenge areas that are listed above. As far as what our goals are just to help Reclamation do its mission better, faster, cheaper, and safer. So we're trying to find solutions to help us increase the amount of water we deliver or the amount of hydropower we generate. We're looking for ways to reduce O&M costs and as we manage our infrastructure, improve worker safety, extend infrastructure life, improve decision-making, make it more confident, and also lead to work towards more effective environmental compliance. So given those general objectives, we put into play a few different types of innovation tools. The key one, the traditional one, has been research projects led by outside experts or internal engineers and scientists. But two of the more recently added tools to our portfolio are prize competitions and technology transfer partnerships with industry. So what I'm going to do is kind of walk you through each of these tool areas and give you some project examples to give you a flavor of the kind of research that we invest in. So starting with research, to get a sense for what we invest in, this chart shows that with just the S&T program alone, we maintain a fairly balanced portfolio of investing in projects across those 5 challenge areas. I mentioned them before: water infrastructure, power and energy, environmental issues, water ops and planning, and developing water supplies. These latter 2 are water ops and planning and environmental issues are relatively large at the moment because we have a couple priority initiatives. One is open water data, that's in the water ops and planning, and the other is addressing the challenges of invasive zebra and quagga mussels, and that's in environmental issues. Our process to identify what types of investments to pursue, it really starts with engagement with the users. We're engaging with facility managers, resource managers, assessing their needs, getting their input, and we roll that up periodically into science strategies and research roadmaps. We communicate those roadmaps and strategies to our community of researchers who are going to pitch proposals. We invest in various types of research projects. They may range from more formative, like science investigations, lab studies, to something much more mature, like demonstration in the field of prototype technology. And so I'll show you some examples. Annually, we issue competitive calls for proposals from both of the 2 programs. The DWPR program, it focuses on externally led research, so we announce a funding opportunity to a community of non-fed researchers in academia, private sector, nonprofits, and they can pitch research studies or pilot projects. With S&T, what we do there is we actually aim the call internally, so that projects are proposed and led by Reclamation engineers and scientists. The philosophy there is these are experts that work within Reclamation and understand our technical challenges intimately, and they're well positioned to frame the right kind of applied R&D project that's going to produce results we can readily use. They can partner with people from the outside, but we want to make sure those projects are internally led. And then outside those competitive calls, we're also brokering research as needs and opportunities arise. So that's kind of an overview of the process. I'm just going to walk through those 5 research areas and give you some examples of challenges and research response to provide solutions. So I'm going to start with water infrastructure and talk about a few examples. So the first is the matter of assessing canal health. So we have thousands of miles of canals in our infrastructure fleet, and these are located throughout the West. They were built many decades ago, typically in rural areas, and over time, the nearby town has grown. Urban encroachment has occurred for many of these canal reaches. So not only are the canals aging, but they're also aging in more sensitive areas with urban encroachment. So there's a need to repeatedly assess the health of the canals, and one other factor is we don't necessarily have a lot of financial resources to go out and refurbish long reaches of many canals. We have to be strategic and focused and focus on the problem spots and identify them efficiently. So how do we rapidly and recurringly assess canal health so that we can prioritize maintenance and repairs is the key question. We're investing in various types of sensing technologies that are going to provide this kind of screening capability. And the one I'm just going to highlight is a technology that we recently tested and evaluated at South Canal in the Gunnison Basin in Colorado the last couple of years. And the idea here is we're combining 2 different types of sensors. One is EM-MAG, it's magnetic profiling. The gist is you're trying to sense moisture in the canal embankment, and so you'll get a relative variation of the moisture conditions in the embankment as you drive by taking these profiles. And then if you couple that with vegetation sensing information, so from satellites we can sense vegetation at reasonable resolution along the canal reaches, and that will help the presence of vegetation will help corroborate information you get from the EM-MAG. So what we can do then is convert that into basically a seepage index running the length of the canal, and that can tell asset managers kind of where their hotspots are and help them prioritize the deployment of maintenance resources. Moving forward, we're going to also look at the use of UAS or drones and sensing platforms, sensing equipment on those to help make the process even more efficient. Another problem that we have with our aging facilities is maintaining a good awareness of just what's in them. So these dams, they were built many decades ago. The construction was guided by engineering documents, and then after they were built, you have these as-built documents. But then time passes and certain subsystems get refurbished or upgraded, and those subsystems have their as-builts, and it becomes this kind of complicated process of maintaining an evolving library of engineering documents that describes the state of the facility. It challenges asset managers, it challenges facility managers who are trying to communicate requirements to designers who are designing upgrades. And so to try to make that process more reliable, more efficient, our Upper Colorado region put in a proposal to our S&T program, teaming with Autodesk, to apply modern surveying technologies and develop a building information model that can be expanded upon over time. So this involved mounting sonar on a watercraft to collect bathymetry information downstream of the reservoir and upstream of the reservoir. We mounted photo equipment on a helicopter and did photogrammetry outside the reservoir. And inside the power plant, we flew a UAS, and basically we're just and did photogrammetry and LiDAR within the power plant. And what that allowed us to do, using Autodesk technology, is develop point clouds that basically render what's there in the facility as it exists today. And so that's really great for orienting new designers to the organization who are being put onto upgrade projects, or it's great for orienting vendors who are putting in bids to bid these projects, but they're not really familiar with the facility. We can offer these digital renderings. So we're excited about this first pilot, and we're planning to also apply it to more fine-scale systems within the facilities, like mechanical systems and electrical systems going forward. Another infrastructure challenge is the matter of dealing with coatings management in our large pipelines. We have pipelines and penstocks that are 10 to 20 feet in diameter in various facilities in the West, and they have these coatings that over time, with water flowing through the pipeline, the coatings degrade, and they have to be replaced with something new. Well, the process is really labor intensive. It's difficult. You have to put this complicated scaffolding, as you see here on the right. This is a pipeline near Glen Canyon. And you can only really do work in the vicinity of that scaffolding. So first you'd use this abrasive blast media process to remove what the coating that's left. It's not a great worker environment. And then you apply the new coating, and then you clean up and you move the scaffolding forward. And it's just a very time-consuming process, makes outages longer. So we're looking for a quicker, safer way to apply coatings. So one approach that's really kind of come onto the market the last couple of years is robotics controlled coating operation. It sounds great for making things quicker, reducing worker exposure, but we're not familiar with how effective it is. And if you rely on this, is it going to apply a new coating that's going to last, or are you going to have problems? You have to go in there and fix it. So we have a S&T project where we're going to follow some pilot applications of this technology and have independent evaluation done by our technical service center staff, and that's going to be communicated to our facility managers, who can then come up with a more confident assessment if this is the type of technology they should use. Another infrastructure problem that I'll just briefly highlight is the matter of rockfall hazards. This occurs at many of our facilities. This particular location is up above the visitor center parking lot at Hoover Dam on the Colorado River. And what happens is, over time with weather cycles, cold, warm, freeze, thaw, rock becomes unstable on these rock faces. And the way we've traditionally monitored these hazards is we deploy rope teams to inspect certain areas that were thought to be a problem. And so it leads to some of the surface area getting inspected, but not all. And so there's remaining risk, and it also puts rope teams at risk themselves. So we're looking for quicker, safer ways of doing this. And the way we recently evaluated it involves using a drone or an unmanned aerial system mounted with a camera, and then doing photogrammetry analysis. So basically, if you take photos of the same surface from different angles, you can create a 3D model of that surface. And if you do that same flight repeatedly, but let time pass, you can detect changes in that surface over time, and then that can kind of tell you where there's a hot spot of rock movement, and then you can do more focused deployment of your rope team. So we're pretty excited about these results. Our Lower Colorado region is a partner on this, and they're also interested in how they can keep applying this. I'm going to switch gears now to power and energy. So with generating electricity at our hydropower plants, periodically we have to take these hydro machines out of service. What happens is, when you flow water through these turbines, cavitation happens. Some of that cavitation is erosive. It pits the steel. Those pits grow larger over time. If you keep the units in operation longer, the erosion will be worse. So managing that cavitation is a guessing game for facility managers, because you can't really observe the cavitation easily right now as it's happening. It's kind of a rule of thumb: how much do we think is happening, and then we'll take the unit out for X amount of time. Another issue is kind of on a decade scale, how much more service life does a given component in these hydro machine have? So, like, for example, the spinning rotor that's used to generate electricity, how much more stress can it withstand? And should you replace it now, or can you let it go for another 5-10 years? So what would be really helpful is if there were better cavitation monitoring technologies while the unit's in operation, and also residual stress measurement instruments that could be deployed to facilities that can be easily applied and give facility managers better intel on what's the remaining service life for these steel components. So to develop such technologies, we've recently partnered with General Electric and Bonneville Power Administration, and we're developing such systems. So with cavitation monitoring, General Electric has some new equipment for measuring sound emissions from these hydro machines while they're in operation, and then they have algorithms that are unteasing signals from those sound emissions to kind of discern what's erosive or not erosive cavitation. It's very theoretical right now, but the concept's pretty promising. And then for residual stress measurement technique, the deluxe method would involve this X-ray based sensing, but you can't really get into nooks and crannies, kind of hard to reach configurations within the steel infrastructure. So there's another type of technique, bark and noise, that is being tested alongside the X-ray technique with the GE engineers and also our staff. And they're hopeful that the results will correlate well. And if so, the bark and noise approach will be something that can be more broadly applied at our other facilities. Another type of a problem that we're dealing with in power and energy is the question of, can we generate energy from the water flow in our canals? So this gets asked pretty often. There are some small hydro development companies that develop turbine technology that could be erected in canals, but there are remaining questions. Okay, what would that do to the water levels? How does it affect maintenance of those canals? And so there's kind of outstanding questions. Further, the demonstrations that have been done to date have only been a single turbine at one location. There hasn't been a demonstration of an array of them in series. And what's the cumulative effect if you have many? So last year we had the opportunity to start a partnership with Denver Water and their subcontractor, a company called Emergy, who develops these types of turbines. And they were looking for a facility where they could demonstrate their turbines and see how effective they were. And so we helped them get 3 of them installed in South Boulder Canal near Golden, Colorado. And then we also brought in hydraulic engineers from Reclamation's Technical Service Center who are independently assessing the effectiveness of what's happening in the canal, as well as the water level and canal stress impact. So we think this information is going to be very valuable that we can share more broadly around reclamation once the study's done. I'll move on now to environmental issues, and I could talk about many types of projects where we're developing tools to better monitor aquatic and riparian resources and supports species recovery programs and environmental compliance activities. But the one project I'm just going to focus on here, it deals with controlling impacts of invasive zebra and quagga mussels. So these mussels were discovered in Colorado Basin the late 2000s, and from that point forward, the focus really was on mitigation of impacts and just try to control their settlement in sensitive infrastructure. And one category of sensitive infrastructure are these small pipe systems that are in our dams and hydropower facilities. So for example, hydropower generators, they need cooling water to assist the machine while it's in operation. But if mussels get into that cooling water system and clog it, that could put the whole hydropower operation in jeopardy. So we evaluated different types of technologies to discourage mussel settlement in the cooling water systems, and after several years of piloting at Parker Dam, the technology that really came to the forefront was, through our Science and Technology program support, was this inline ultraviolet light treatment scheme. Basically, the UV light will kill the veligers, the really juvenile mussels, before they can adhere to the sides of the pipe and then settle and grow into adults and form shells, and away they go. So it showed effectiveness of killing veligers, and then it's also the byproduct that there was benefits that it reduced biofouling that was naturally happening in the pipes as well. So it was kind of a twofold benefit. I'll also come back to mussels when I talk about prize competitions, because we're also exploring ways to eradicate mussels from open water bodies as well. Another research area is water operations and planning. In this area, we're investing in different types of decision support tools, new approaches for water forecasting, stream flow forecasting. The one activity I'm going to highlight here is one that we've been focusing on in recent years, and that is developing new IT systems that help us do a better job publishing and sharing our data, our water and water-related data, for the public and private sectors. The idea is to stimulate economic growth and just increase transparency and access to all this information we collect. Before this initiative, the status quo was we have many programs in reclamation that collect a lot of information, and they share it with different slices of stakeholders in different ways. So we have this diversity of legacy approaches, and also when they're done at the program level, it's hard to roll up that information at the corporate level. So that was a reality, and then if you consider that alongside IT technology just continues to evolve, IT security risks continue to evolve, and then there's expectation at the federal level just to make our data more open and transparent. It's hard to efficiently meet that federal mandate and deal with these IT trends while having such a dispersed approach to data management and data sharing. So our program has been funding the development of a couple IT systems to help chart a new direction. So the first we focused on was developing what we call the Reclamation Water Information System. It's at water.usbr.gov. It was launched in April of 2017. A big cast of characters, about 50 people reclamation-wide, had some type of contribution to develop this system. We worked with data owners from our 5 regions that have reservoir operations data stored in their own region databases, and we worked with them to come up with a consolidation scheme to consolidate those data into one central consolidated publishing database. And then we developed a user interface through a public website that had several modern features. So if a user comes to RWIS, they can go to a map interface that allows them to select sites that are of interest to them. They can send those sites to a query form and pick which types of variables or parameters are of interest and what historical period. They can inspect the time series of those data just to get a sense for what's there. And then once they know what they want, they can export the data in various machine-readable formats. And then the other really nice new feature of this data publishing approach is that it produces a web address or a URL that can be included in some type of auto-retrieve program. So all this can be automated. It doesn't have to be manual once you know once you've identified what you want. RWIS was a successful pilot, so what we've done is expanded the scope considerably into a new system that's in development now called the Reclamation Information Sharing Environment, or RWIS. And it's going to serve different types of data that we collect across the organization, not just reservoir water data. So hydropower generation, infrastructure assets, different environmental programs like species data or water quality data that constrains our management. So that different types of information will be served. Also, we'll go beyond time series to serve like map or geospatial data, documents, videos, imagery, etc. And there will be user customization also offered through the interface, so hopefully it better serves the user community. So we're excited about the coming of RISE. We expect it to be launched summer, fall 2019. The last area I'm going to talk about for research is the matter of developing water supplies. A lot of what we do in this area focuses on the application of treatment technologies to convert non-typical water sources into something we can use. So that's like seawater, brackish groundwater, water produced from oil and gas extraction, municipal wastewater. This slide is just focusing on the matter of trying to harvest municipal wastewater more effectively and more directly. There's this concept called direct potable reuse, where the idea technically is if you apply a train of advanced water treatment processes to the effluent of municipal wastewater, you can treat it well enough that it can be used directly for drinking water. And this concept's been around since the late 90s. It kind of fell out of political favor, but it's come back in recent years. As it's come back in recent years, there are just questions being asked about certain types of treatment units in that treatment train, like reverse osmosis. Reverse osmosis, its legacy is it was developed to remove salts for desalination, but engineers know it can also remove pathogens, but they don't know how well. So to help regulators, and regulators don't know that as well, but they're interested. So this was a question that was posed in a pilot project proposal by this San Diego Water Authority to our desalination water purification research program a couple years ago. And in their proposal, they had a demonstration facility, their North City demonstration facility, and they set up monitoring equipment to quantify the capability of a typical RO unit to remove pathogens and thus help regulators confidently estimate what the treatment credits ought to be for the RO unit in that treatment train. So it just moves the water utility community one step closer to being able to access municipal wastewater through direct potable reuse. Through this area, we also fund the O&M of a dedicated research facility that Reclamation owns. It's the Brackish Groundwater National Desalination Research Facility. It's in Alamogordo, New Mexico. At this facility, we host R&D clients from private sector, from the university community, and they are allowed to come in and test their prototype water treatment technologies under different feed water conditions, so different quality groundwaters, et cetera. There's also ag plots outside the community, so they can test technologies on the application of salt concentrate, the waste stream, if you will, from Desal, and look at plants that can tolerate that. So Bergendorf is in Alamogordo, New Mexico. Okay, so that's a lot on research. I'm going to switch gears to prize competitions, which is a complementary tool in what we fund. We typically apply prize competitions to technical challenges that have been around a long time, where traditional research has really not been able to move the needle very well. And we realized that we've been seeking solutions through research from kind of the familiar faces in that discipline community. But the idea with the prize competition is you issue a challenge super broad. It's like a nationwide solver community, clever people from other fields who may have relatable expertise that can be applied to our challenge and come up with a novel idea or a novel solution, and perhaps reset the research starting point or give us something mature that we can move even faster with. So that's the paradigm of prize competitions. In order to incentivize that nationwide solver community to engaging, we offer a prize purse. We only pay for success. So there's just the admin cost to launch the competition. We may get, how well we do outreach will affect how many people engage and submit solutions. Basically we set a bar, what the criteria are for success, and those who pass it, then they compete amongst themselves for who wins prize purse. Our first experience with prize competitions occurred with teaming with USAID in 2013 through 2015. USAID was leading what they called the Desal Prize. And their goal was to address rural water scarcity by developing brackish water desalination technology that could serve a family of 4, provide their potable water needs and their irrigated ag needs, and be renewable energy powered. So this competition it took place and culminated in a field demonstration week with finalists demonstrating their technologies at our Bergendorf facility in April 2015. And the winner who succeeded in this competition, part of their success was they teamed with a manufacturer in India, Tata Industries, who was poised to implement and manufacture their technology, which really was just an application of an old technology to a new problem. And so that was pretty novel, and they've been successful in implementing it since. And the winner has also been teaming with Reclamation at the Bergendorf facility to further refine their technology for application here in the U.S. So that's been a nice success from that first experience. Concurrent with that Desal Prize, we were also developing our internal capacities to host our own competition. So we launched the Water Prize Competition Center in 2015. Since then, we've launched 17 competitions addressing different challenges in water availability, infrastructure sustainability, and environmental compliance. We leverage federal and non-federal partners to help us design these competitions and help us judge them. And so we have many more planned in the coming years. I'm just going to highlight a couple of them to give you a sense for what type of challenges we're aiming at and what the reaction has been from the solver community. Excuse me. So the first that I'm going to highlight is this challenge of eradicating invasive mussels from open water. So before, when I showed you that UV light example, that was really about just controlling the impacts, just resigning ourselves to, hey, they're in our open water bodies, they're going to get into these pipes, let's just try to keep them out of the pipes. But ideally, we deal with their presence in the reservoir, the lakes. Once zebra and quagga mussels get into our reservoirs and lakes, they're prolific breeders, and their populations can explode pretty quickly. So we described what an ideal solution would look like through a prize competition. Basically something that could be cost effectively deployed and would have minimal ecological impacts. So really focused impact on the invasive mussels community that we're trying to eradicate. A competition was launched in 2017. The solvers just had to submit a theoretical description, like a white paper, describing what the solution concept would be. We had 100 submissions, and after judging phases, we reduced it down to 3 winners. And our internal mussels experts and researchers were really pleased that the solutions that they got from these 3 winners really were novel ideas they hadn't thought about. And that's the whole purpose of a prize competition. And 2 of them dealt with genomic modification. And the one that won first prize was the one that it involved a genomic modification. This is beyond my expertise, but the gist is that it could induce a contagious cancer that could be spread from mussel to mussel. And it really showed potential if you could develop it to crash the population and eradicate it in a focused way. There's a lot of research that needs to be done to validate this concept, but it was substantiated well enough that the judges felt comfortable awarding a prize to this solver. This solver is BioMe Lab from Michigan. And our next steps is we're looking at a research collaboration arrangement with BioMe Lab, and we may explore as well with other winners. And also, coincidentally, 2 of the 3 winning concepts involve genomic modification, and we happen to have a different research project led by an internal reclamation scientist on mapping the zebra quagga mussel genome. We figure, well, that's going to be, once that's done in a couple years, perhaps that could be a data set or a baseline, if you will, that we could do another more focused competition where we could invite solutions that might make use of that information and further innovate. So we'll see where that goes. Another competition that we implemented the last couple years deals with this challenge of better forecasting of subseasonal precipitation and temperature. So what we mean by subseasonal is it's this little time gap in between where we do weather forecasting and later on when we start doing seasonal forecasting. So this chart is borrowed from IRI at Columbia University. It's a kind of a nice summary of how forecast skill on the vertical left axis varies with forecast lead time. So with weather forecasting, we have excellent skill at very, very short lead times, but it diminishes to nothing, say around 21 days, 3 weeks out. 3 weeks out, you really can't forecast with basic weather forecasting approaches. Seasonal forecasting starts to have some fair skill about 6 weeks out and going forward. So there's this gap from 3 week to 6 week where the skill with our traditional forecasting systems used by our federal forecasting agencies just really struggles. But we were aware that there are some statistical and data mining types of techniques, machine learning techniques that might be applied, but we just don't know who would do it and whatnot. So we thought we'd put a challenge out to a nationwide solver community and see if we could get some clever competitors to pitch their own forecasting algorithms. So that led to launching what we call the Subseasonal Forecast Rodeo, and the project manager of that competition happens to be with us today. It's Ken Nowak here in the front of the room. So this competition, it was a reduction to practice, or build it and improve it kind of competition. So solvers were asked to develop a forecasting apparatus and issue forecasts of temperature and precipitation throughout the West every 2 weeks for 1 year. So a real-time competition. And that occurred from last April 2017 to roughly April 2018. They also had to beat a bar, get over a hurdle, and the hurdle was 2 federal forecasting benchmarks. One was this simulation model that NOAA uses called Climate Forecast System version 2, or CFS version 2, and another was a statistical technique, which is just recent conditions foretell what comes, called damped persistence. And then there's other submissions that solvers had to do after the real-time year. So we're getting ready shortly after the holidays to issue a press release on announcing the winners. I can preview that we're really pleased that we had some decent solver engagement, and in every forecasting category we had solvers that beat the federal benchmarks. So there's some new ideas. The one anecdote that I am going to share here is that we did have 2 solvers drop out of the competition at the very end. And the reason they did this was really interesting, and we viewed it as a success. So in the temperature categories, the person who was winning chose a team name that didn't really hide that person's identity. And then in the other team, that was PRXWX, they reached out, and eventually they hired that person. And with that, the hiring, they absorbed that person's solution IP, and they're busy working together to commercialize that solution. So even though we're still curious, we like to know how'd you do it. It's comforting to know that it's on its way towards some market solution. So we feel like the competition led to a successful outcome for those two. In the meantime, we had other competitors that also beat the federal benchmarks, and we'll be announcing them as winners here soon. So I'm going to wrap up with a few slides on technology transfer partnerships with industry. If there's one thing to walk away with as far as being awareness of what technology transfer is in our world, it's basically non-funded or in-kind flexible agreements with industry to co-innovate together. So often we have CRADA agreements, which are cooperative research and development agreements. We have material transfer agreements, facility use service agreements. These are all tools that these technology transfer authorities give us as a federal agency to help push our inventions into the private sector for further development, and helps industry pull those inventions into something they can manufacture and commercialize. So it's a great set of authorities that allows us to co-innovate with the private sector. One category of treatment technologies that we have been really trying to explore tech transfer agreements with industry. It involves membranes that are used in desalination. We have reclamation water treatment engineers that were very clever and developed two unique types of membranes that they were able to patent. The gist of what made them patentable was these two types of membranes offer chlorine resistance, which is very attractive to the desalination industry. Presence of chlorine in the water tends to degrade the membrane and reduces their service life, increases O&M, just increases the cost. So if you can find chlorine-resistant membranes, that's great. So they have patented inventions. The next question is who can manufacture it and who is inclined to manufacture it. So that's what we're busy exploring. We did enter into a CRADA with one prospective manufacturer, and they were able to produce the membranes, but then their business plan shifted. So sometimes those tech transfer agreements reach a dead end. But right now we're working with an entity called FedTech, and they're going to help us restart exploration of potential industry partners that could address this manufacturing challenge. Another type of invention that occurred in reclamation that is now being manufactured in the private sector, and we call it a flexible flux probe, or TF probe. And our electrical engineers in Denver recognized that they didn't have very good equipment for diagnosing electrical installation problems in generators and motors, and they needed some small instrumentation to help detect these problems, and they developed this probe. It was novel, they got a patent on it, and since then we've entered into a patent license agreement with RWIS Power, who has successfully manufactured and sold many of these probes throughout the hydropower industry. A couple more slides on tech transfer. We invite private sector entities to come and pilot test or test their prototypes at our various dedicated research facilities. We have a technical service laboratory in Denver with hydraulics and materials labs. I mentioned Bergendorf, and also the Water Quality Improvement Center in Yuma. And also, we have natural labs. All of our reclamation-owned facilities, lands, and waterways really can be settings for the private sector to enter into a tech transfer partnership with us and test their prototype technologies. And we have several examples of those over the years as well. And the last slide I'll share is if you'd like to learn more about Reclamation R&D, you're welcome to visit our public website. We have information on our projects and products. We're planning to modernize the website to kind of lay out the projects where they're occurring geographically, give you a better sense of where we're doing work. Also, we issue a quarterly magazine called The Knowledge Stream. This is thematic by quarter, but it's a great way to learn about R&D programs and activities, and if you'd like to be on the distribution list, I'd be happy to connect you. So with that, I'm happy to take any questions. Thanks.